This short video will discuss extracting the current statistics that we need to create a portfolio model. And in this portfolio model, we're going to create a mixture of large company stocks, small company stocks, corporate bonds, and government bonds. So SPY is an S&P 500 index fund that would represent large companies. FCPVX is a small company stock index fund. SPIB is a corporate bond mutual fund. And PNIGX is a government bond mutual fund. So what we're going to do is, using Python, pull up historical prices. For right now, we'll use the period 2011 up to 2020. And so if we run this file, we'll see the most current prices. And so what we're going to do is calculate the log returns for these prices of these indices. Now, down here, in this area, we've calculated the mean returns, and these are daily prices, and the standard deviation of returns. And this is just done for two of these, just to illustrate the different commands that are required to calculate the means. So if you notice up here, returns is what's called a Python data frame, and that was created when we calculated the returns. It has column names, and it has what's called indices on the left side. The left side is an index, which is basically the row names. And so if we want to calculate the mean for a column in that data frame, we can use this .mean command. And if we assume that there's 252 business days in a year, we can annualize that mean. If we specify a column in that data frame and use STD, that'll be the standard deviation. And then we can annualize that standard deviation in this way. Now, it turns out that what we have to do is multiply the standard deviation times 252, and then take the square root. Okay, so here we have the mean returns for all of the index funds and the standard deviation of the returns for all the index funds. Now, in Python, what we would like to do is calculate both the covariance and the correlation of the returns. So we've looked at the intuition and the meaning behind covariance and correlation, but Python has a function that basically, if we use this command returns.cov, that will calculate the covariance matrix. And if we want to annualize the covariance matrix, we can simply multiply it by 252. And so down here, we calculate the correlation matrix by using .corr on the returns data frame, and it gives us the correlation matrix. The important thing here is to realize that the correlation of each mutual fund with itself is 1. And if we look at these correlations, something like the large company stock SPY and small company stock will have a very high correlation, close to 1, because they're both affected by the stock market. But we see in several cases here that there are negative correlations between the government bond fund and the two stock funds, and really very low positive correlation between the corporate bond funds and the stock funds. So that may be advantageous for developing a portfolio model. All right, so here in this file, we've calculated the means, correlation matrix, and the geometric Brownian motion parameters. And if we go toward the bottom, this is all consolidated in a data frame here. And what's in this data frame is the correlations, the mean, the standard deviation, and then the geometric Brownian motion parameters, and then also the current price. And so this is going to be outputted to an Excel file that's saved in the same folder as the Correlation 1 notebook. And then we'll open that in Excel. So we're going to run all in this file. And we'll have this Excel file in the same folder as the Correlation 1 notebook.